Hello friends, welcome back to MATLAB. Today we are going to learn about how to make a Bode plot in MATLAB. But before that, we have to know what is frequency response analysis. The steady state response of a system to a purely sinusoidal input is defined as frequency response of a system. In such a method, frequency of the input signal is to be varied over a certain range and the resulting response of the system is to be studied. Such system is called the frequency response. Now we learn about Bode plot. So the Bode plot is a frequency response plot of a sinusoidal transfer function of a system. A Bode plot consists of two graphs. One is a plot of magnitude of the sinusoidal function versus the log omega, and the other is a plot of the phase angle of a sinusoidal transfer function versus log omega. So the Bode plot can be drawn for both open loop and closed loop system, but usually it is done for the open loop system. Now let us jump to the MATLAB and see how to make the Bode plot in MATLAB. So for making the Bode plot, first we need a transfer function, and for transfer function we need the numerator and denominator of the transfer function. So I am taking a numerator as 2 and denominator as s square plus s, and I am denoting my transfer function as g1. So the transfer function is this 2 upon s square plus s. And now to make the Bode plot of this, we simply type Bode and in the bracket the transfer function. Now the Bode plot is done, and here you can see the Bode plot. So as discussed earlier, the Bode plot contains two diagrams. First is for magnitude plot and second is for phase plot. Now if we want to compare two Bode plots simultaneously, then we want it on a single graph. So for making the another Bode plot, we again need the numerator and denominators. So I am quickly taking the numerators and denominator, and I am changing the denominator as s square plus 0.5 s. Now the transfer function, now you can see the transfer function as 2 upon s square plus 0.5 s, and now we want to make the Bode plot of the two transfer functions. So here is the Bode plot of two transfer functions simultaneously. So here you can compare the two transfer functions, and this red line is for G1 and the green line is for G2. And here you may notice that there is a huge difference between the phases, and this difference is created because I have changed the zeta value in the denominator, and here you can see that zeta value is 1 for this red diagram, and so the phase margin is more positive than the green diagram's phase margin. So in this way you can compare two Bode plots simultaneously. Now here we can also find the gain margin and phase margin of that Bode plot. So for that we need a Bode plot first. So I am quickly making a Bode plot. So here I have made the Bode plot, and I have made the Bode plot of this function, and the plot is this. Now to find the gain margin and phase margin, we have to simply type the GM and then PM, that is gain margin and phase margin. We can also find the frequency at which the gain margin and phase margin has occurred. So for that we type WGM and then WPM, and now the syntax is margin of the transfer function. Then so the transfer function is G here. Now you can see here in the workspace the GM, PM and all the steps are done. To see that we have to type the variable name. So the GM is 0 and Y we can see it in the figure. So from the definition you should know that we have to check the magnitude at the frequency at which the phase diagram has cut the 180-degree line. So from this diagram you can see that this graph hasn't cut the 180-degree line. So the gain margin is 0 here. Now see the phase margin, and it is shown here the minus 40.975 degree. Now check it in the figure. So in this figure you can see the zero line is crossed here. So the it is almost zero, you can see. So the frequency is here 0.855. Now look it into the the phase response. Now you can see here the phase is minus 2 to 1 degree. So if you add here 180 degree, so you will get minus 41 degree. So it is very near about this phase margin. So in this way you can find the gain and phase margin. Now we look into the frequency in which the phase margin has occurred. So it is shown here 0.8685. So it is very near about of our frequency. So in this way you can draw a Bode plot and find the parameters from it. Thank you for watching this video, and please comment below if you have any doubt, and don't forget to subscribe this channel.